So yes, my talk will be about the next big step for the ROS middleware. When we filled that proposal in December, we were expecting to have more time working on that. So it will be more like an outlook, what we've already done and what we expect to do in the future. So the next big step, we call it ROS 2.0. ROS is great as it is. It's successful. People use it. You save time, as we've heard before. But there's always room for improvement. There are a couple of points which we think are not the best things which we currently have in ROS. So we have implemented everything from scratch, custom TCP communication, custom serialization, because at that time, when it was initially started, like 5-6 years ago, there was basically nothing adequate available which we could use. So a lot of stuff was developed from scratch. A lot of features which we now would like to see weren't necessary in the first years of ROS, and so they're probably not supported and difficult to add them later, like unreliable transports, when you just have a request and response and the message just gets lost. Well, you will never be notified. There is no timeout mechanism or something like that. Also, when people think about industrial applications and would like to have a normal deterministic startup behavior of ROS, well, that's also not possible. The nodes come up when they come up, if they come up, but you have no way of checking or validating that. Then if you implement code, you have to decide if you want to have nodes or nodelets. They have different API because they have been designed at different times. First, they were only nodes. Later, the demand for nodelets came, so they're not really interchangeable. And then, at that time, the project was focused on getting the software running on one robot. Nobody was expecting to use it on a lot of robots or multi-robots in a swarm. And the system is not very introspectable, so you cannot really look into what's going on and react dynamically on changing things. So these are all goals over time we've collected, which we would like to change, where we want to get improvements to better address the needs of the current time and also for the next years. So we want to reuse more libraries which now exist. We have serialization libraries which we could use out of the box. We want to reduce the maintenance work of the core team in order to develop new stuff and not maintain thousands of lines of code which are already backdating a couple of years. We want to keep the system more modular than it is currently. It is well structured currently and modular to some degree. But there are so many people using ROS in so many different ways and domains that the more modular we get the infrastructure, the better we can suit it to your specific domain. And at best, we should be able to introspect the system more deeply, to be, at best, having a dynamic system. If the system detects, oh, this bandwidth is going to be saturated, then I can adjust dynamically my rate. All these things are currently not or very difficult to achieve. I will not go on all the points from the slide. The list of goals is pretty much extremely long, and everybody could contribute more points to that. So why do we call it ROS 2.0 and not ROS 1.x plus? I don't know. Because I got the question, hey, ROS CBP was version 1.8 in Fuerte. So Groovy was 1.9. So is Hydra 2.0? No, Hydra is 1.10. So we can continue that until we really make the step to 2.0. I already stated the issue with having a node and a nodelet, which is difficult to decide that at programming time because I cannot decide it at runtime. I have to make the decision much earlier. If we want to change that, if we want to have a unified API, which one of the two are we going to break? It's not possible to merge them easily. Hopefully we can provide a backward API to map to something new that we don't break existing code on that level. ROS, as we've seen in other talks before, has two different wire protocols. You talk with an XML RPC to the master and to the other nodes to negotiate things, and then they talk TCP ROS or UDP if you're a C++ client. Why do we need two protocols? One protocol would be technically perfectly enough. So in order to reduce maintenance, it's probably feasible to just go to one wire protocol and reduce the code size. Currently, we don't have deterministic startup behavior. And One point which might contribute to that one is like every node writes its own main function. So ROS, the framework, doesn't have any control about how you start your main. We need a more structured way to make that generic over multiple nodes. That could be a component with a life cycle, or just like recommendations how to write a main function to make it deterministic in startup, that you can have a startup phase, all node starts. If they are really running and all connections have been established, then you start really exchanging messages. And then there is the point that ROS currently has a single master only. And we have applications where we would like to have multiple masters. Or people would say, I have applications where I don't need a master at all. I would like to use like a peer-to-peer like system where the stuff discovers itself automatically. How could we like address these needs? Is one solution really fitting for all use cases, or do we have to support multiple of those? So ROS 2.0 is only describing all these efforts. It's not like a fixed feature set and we will deliver on a specific day. It's more everything which we have in mind for like updating these things and making innovations and making new decisions in the design, and probably merging a lot of features which have been like built on top in ROS over the last couple of years. There are definitely a lot of API changes implied by these. So if we think about nodes and nodelets, some API has to change there in order to make it unified. And deploying them iteratively in the current ROS releases, so every release a little bit, is not only a significant overhead, but also dangerous for stability. So people might prefer to have a clean API, which is currently stable, and the new stuff gets developed side by side. And as soon as it's getting mature enough that it can be used after like longer time of testing, then you can switch to the new API. Hopefully, we can provide compatibility features that this transition is easy, or at least make it that you can transform one node, and then the one old node talks to the one new node, and you don't care that they are using two different versions of ROS, for example. So the approach we're currently heading towards is we want to like figure out what really the protocols, the abstract protocols are, and what the interface between the different modules in ROS are. So what do I need for serializing, for transport? How can I like cleanly separate them from each other in order to like make them at best pluggable? So we might make a decision to use a specific kind of transport layer today. The decision might be different from what they decided 5-6 years ago. But who knows if in 3 years there's a different transport library available, which is much better, much faster, much smaller in bandwidth. So the goal for that one is to keep things pluggable and separated, that we can like make changes in the future and also allow other people to provide different implementations if they fit their needs and their purpose or use case better. And if it is that API changes are really necessary to like code you usually interface with, then that should be in a way that either there is a clean upgrade path, or that if you have new code, as mentioned before, just be able to communicate like a normal ROS network with each other with an older node. So you would like not see that both are running different API behind the scene. The main problem of this like ROS 2.0 effort is that it affects so many subsystems. Probably subsystems you never cared about, that they're actually under the hood. Message specification and serialization, as well as the transport, that's usually the first thing to grasp because that's the core communication part for ROS. But it's also that a lot of capabilities we have, like topics, service, and actions, we have to like refine what we need for like a transport protocol. Because for a service, it's really a disaster if the response doesn't arrive me. On a topic where I fan out TF information, like 100 hertz, it doesn't matter if one of the packages probably get lost. But that's up to the user to decide. He has to be able to like say, this one must be reliable. And currently, we don't have a way to specify that. So these services and features we provide for the communication, they really drive the requirements of the lower level transport layer. For the network level, There's also the question about single, multi-master, no master. What do we do? What do we need for discovery? How do we do negotiation? How do we find out if we have like 2 different transport protocols, which one to use? Like we can probably learn from other domains how HTTP connections do that. They, on discovery, decide what kind of protocols are you able to talk, and then figure out and selecting one. Or probably the user wants to define that in a custom configuration file because he knows better instead of what the system would take as a default. And beside all these things, when we want mostly more flexibility and more pluggable functionality in the system, there comes the problem of how do I manage all this configuration? Some things I might configure at build time or at deploy time. At best, I can change stuff at runtime. And all these must be like configurable in a way that the user does not have to fill hundreds and thousands of like different configuration flags, but the system must provide a reasonable default behavior. And then if the user has good knowledge about that he wants to have it very specifically different in certain use cases, then he needs to be able to like override that. And this configuration part will be pretty complex. Because currently, if you program your node, you would select between, I want to use a TCP connection or a UDP connection, which is a decision at build time, basically in the code, hard-coded. In a perfect world, you would be able to specify that at runtime, so you would start the node and say, okay, now switch to UDP, because I know that this is now the correct choice, or the better choice for that use case, because I'm using a wireless connection, for example. So what have we achieved until now? When we started this effort, we started from the bottom up. So the first thing we looked at for Groovy, mostly and also in Forte, was we started at the build system, because that's used for everything we use. The build system was the first step to like revamp that and make it hopefully more standard compliant, more straightforward, and also less code. The build infrastructure using that kind of build system to produce the Debian packages and running documentation jobs on the farm, that was basically a significant part of the time we spent during the Hydro cycle. We are not yet completely done with the Hydro cycle, but hopefully until Hydro gets released, we will have a build farm which allows you to run your own build farm. For example, in a company, you don't want to publish the Debian packages, but you don't want to build everything from source. So you should be able to use our build farm and do the same thing as we do on the servers we run. For the higher level, so for the communication, we have only spent less time than we would like to, because we have so many other things also to address. But we have been prototyping, especially Morten has spent significant amount of time of his internship in writing a prototype to try a component-based lifecycle to get this like predictable startup and deterministic startup behavior, and also be able to introspect the system. And this prototype gives us good experience where the system can go to. So it's like learning a lot from these kind of prototypes. But there are much more prototypes we have to do. So that will be an ongoing process. In order to get like a better picture what we want to go for and what's a priority for the development cycle, we are currently in the phase of collecting more use cases and trying to extract requirements from them. But use cases are always specific and tailored for your domain. So they might be different for you. So I'll come later on the next slide that we look forward for people who contribute new use cases in the near future. And then based on these requirements, we have to derive design decisions. It will be difficult to come to a consensus on some of the design decisions, but that will be an ongoing process. And we will very likely announce soon on ROS users probably a process how people can contribute use cases, how we pre-structure them, how you should describe your use case. And in order from that, after they get like classified, because there might be use cases which are really great, but which we cannot cover in the near future. Or there might be use cases which we classify as, yeah, but we would prefer something else. So they must be like agreed on which use cases are the ones we want to like address first, and then come to a design requirement based on these use cases. And one important thing is why we like want to pre-structure that process is we want to make that process like document it, and allow the people to follow that. So if somebody comes in a year and reads the use cases, he must follow the argumentation chain to like, why did we do design decisions and why is it implemented as it is? Because it doesn't help if in a year somebody comes and says, well, we should make it different, but you should be able to follow why the decision has been made. That's the only way to like get a sustainable solution and probably refine it if you get new use cases or you find a flaw in your design process. Then you can reiterate and come to a different conclusion. So that traceability will be one of the challenges in that process. So this diagram is basically indicating the common development cycle. It's inspired by another project. And basically, in the first stage, you try to collect use cases and derive requirements from that one. And then in the next stage, you will come up with a conceptual design. You make drafts on a whiteboard. You do technology research, probably evaluate a couple of, implement some prototypes, learn from them, throw them away. And in the next stage, formalize the system and have prototypes for all these subcomponents in order to know that the stuff you've designed and really like try to evaluate is the right direction or is at least feasible. So this will not be like a 1, 2, 3 process, but we will probably have a lot of iterations and cycles on them to like reiterate and add more use cases with the time. Still, the ambitious goal for that is to have something which we can show in the first half of 2014. So basically next year, in roughly a year, that you can see like a first thing, how to address certain of these components, how they could look like, and get people to look at them and try them out. It will not be like production quality or ready to use, but people should get experience with it and provide feedback. And based on that, like do another iteration and come up with a first release by the end of, or by the second half of 2014, which might be side by side between the current ROS infrastructure, but it should be usable for the people, and hopefully also like integratable with the old system. It should not be like completely standalone. So don't expect the first release to be like, hey, that's everything ROS currently has. That's the new system. It does all the job. It could be that like it covers like the core new functionality, and tooling and things like these, they will evolve over time. So that will be a process which takes longer. So don't expect a final release like on a fixed date, which will just like be a replacement for everything we have. It will be a long-term process. But starting this now and like spending time on that, that's what we're looking to do in the next month or even years. So I guess for that topic, we've got a lot of questions. So please.